In this video, we're going to talk about logarithmic functions. So we've seen exponential functions. Let's just remind ourselves that when you have a constant b, which is positive and not equal to 1, then you get this exponential function y equals b to the x power. So for example, if b is 2, then you get y equals 2 to the x power. Let's make a table of the x values and some y values. So if x is, let's just plug in some integers. If you plug in -3 into y equals 2 to the x, you get 1/8, and then you get 1/4, and then 1/2, 1, and then 2, 4, and then 8. Okay, and that takes these x values to the y values, but there's a function that takes the y values back to the x values, and that's called log sub 2 of x. Okay, so log sub 2 of, let's just write it as c so that I don't get the, well, no, let's use x. Log sub 2 of x is a number for a number x. So log sub 2 of x is the power say y such that 2 to the y equals x. So, for example, we know that 2 to the third power is 8, right? So what that means in terms of log sub 2 is that when you plug in 8, you get 3. So the log sub 2 function undoes what the function 2 to the x does. So another way of phrasing this is that log sub 2 of 8 is the answer to the question, what power do I have to raise 2 to get 8? And the answer is 3. So log sub 2 will take those y values back to the x values. So let's make a table for the function y equals log sub 2 of x. So if x is 1/8, then log sub 2 of 1/8 is -3, and so on. You see what's going on? Is all I did was I switched the x and the y values. So log sub 2 of 1/8 is -3 because 2 to the -3 power is 1/8. So saying 2 to the -3 power is 1/8 is the same as saying that log sub 2 of 1/8 is -3. Well, let's practice rewriting these expressions. So let's write the following expressions that are in terms of exponents in terms of logarithms. So the first one is 64 equals 4 cubed. So what does that say in terms of logarithms? So the subscript in the log would be the base. So this 4 is the base, right? That 3 is the exponent, or the power. So my base is going to be 4, so that's the subscript 4. Okay. And 4 cubed is 64. So that means that when I plug in 64 into my log 4 function, I have to get 3, because 3 is the power that you raise 4 to get 64. So maybe I'll use a different color. So this 64 goes in there, and this 3 goes here. Okay. So another example, 9 equals 3 squared. How would you rewrite it in terms of logarithms? It's log base 3 of 9 equals 2. Okay. By the way, the parentheses here are optional. So you could either put it or sometimes you don't have to. I mean, you can if you want. I like to put it because it emphasizes that it's a function. That I'm plugging in 9 into the log sub 3 function. But it's okay if there's no parentheses around the 9. Anyway. So why is it log sub 3 of 9 equals 2? Because 3 is my base, 2 is my exponent, and 9 is the result. So when I plug in, again, I'm looking at the function 3 to the x. When I plug in x equals 2, I get y equals 9. So I have the function that does the opposite, that's called the inverse. Log sub 3, when I plug in the y value, I have to get the x value. So when I plug in 9, I get 2. So when x is 9 in the log sub 3 function, I get y equals 2. And notice that what's supposed to happen is that the order gets switched. And the reason is because the log sub 3 function takes the outputs of the function 3 to the x back to the inputs. Let's do some practice problems going the other way. So log sub 10 of 0.01 equals negative 2. What's that mean in terms of exponents? So I look at the base, that's 10. My exponent is negative 2, and the result is 0.01. Okay, which is a true statement. Let's do one more. Log sub 4 of 64 equals 3. What's that in terms of exponents? 4 cubed is 64. Okay. Another thing to know, so that takes some practice to get used to this, but one thing that helps is to draw these little arrows. So when you have the base raised to the power equals 64. And then that can help you remember the order. Another thing to note is that when you just have log like this means log base 10. Okay. So for instance, a log of 100 is log sub 10 of 100. Now what is log sub 10 of 100? Well, it's what power do I have to raise 10 to in order to get 100? And that's 2, because 10 squared is 100. Okay? So let's do some more problems to practice. So what's log sub 2 of 4? Well, remember, I'm asking myself, 2 to what power equals 4? The answer is 2. What about log sub 10? Again, you don't have to write down the 10 because because when you have just log by itself, it's base 10. So log sub 10 of 10,000 is 4 because 10 to the 4th power is 10,000. What's log sub 5 of 1? So we have to ask ourselves, okay, 5 to what power is equal to 1? So if I have 5 raised to something equals 1, what goes in the blank? 0. Okay. So log sub 5 of 1 is 0. And in general, if b is greater than 0 and b is not 1, so we have a logarithmic function log sub b of 1, okay, that's going to be 0 because b to the 0 power is 1. What about log sub 1,257 of 1,257? Well, we have to ask ourselves, so here's the base, right? So 1,257 is the base, and we're asking ourselves what power, so let's call this number x, okay, that we're trying to find. So what x do we have to raise 1,257 to in order to get this number, 1,257? Well, now we know what the answer is. It's 1. So x is equal to 1. So in general, log sub b of b is 1 because b to the 1st power is b. What about log sub b of b squared? Well, that's 2 because if you raise b to the 2nd power, you get b squared. Because b raised to the power of 2, I just don't want to write b squared equals b squared, so that's why I'm writing it in words. Raised to the power of 2 is b squared. So now we see where we're going, right? In general, log sub b of b to the c is equal to c. Because b raised to c power is b to the c power. Okay. So this is really just a fact that drops out of the definition of log sub b. So let's put that in the box and let's put this in the box. Okay. Let's do another example. How about log sub 64 of 1/8? We'll take a moment and try to figure this one out. So again, it helps to convert this into a statement about exponents. So let's call it x, and let's rewrite this in terms of exponents. So 64th x power is 1/8. So we're asking ourselves, what do you have to raise 64 to get 1/8? Well, hopefully you recognize that 8 is the square root of 64. So we know that 64 to the 1/2 power is 8. Now what do I have to do to get 1 over 8? I have to take the reciprocal. So I have to raise that to the negative 1 power. So if I raise 64 to the negative 1/2 power, I get 1 over 8. So that means that x is negative 1/2. Okay. What about log sub 25 of 5? So 25 raised to what power is 5? a half, right? Because I'm taking the square root. What if I had a problem that was to solve for x if log sub x of 49 is 2. So again, we're going to convert this into a statement about exponents so that we can better understand what this is saying. This is saying that x squared is 49. Well, if you were to solve x squared equals 49, you would get two solutions, right? You would get 7 and negative 7. However, remember that when we're talking about the log sub b, okay, the base has to be positive. So x has to be 7. So it's log sub 7 of 49 is 2, not log sub negative 7 of 49 is 2. Okay. Because we need, that needs to be positive. What about log sub 8 of 4 equals x? Okay, this one's a bit trickier. So again, we rewrite it as x to the 8th equals 4. Can you figure out what x is going to be? Remember that 8 and 4 are both powers of 2, and when I have that, I can rewrite things in terms of the same base. So 8 is 2 cubed, so 2 cubed to the x power is 4. Now I'm using my properties of exponents, that this is 2 raised to 3x power. That's equal to, oh, I should write 4 in terms of exponents too. 2 squared. So this tells me that 3x is equal to 2. Now I divide both sides by 3, I get x is 2/3. Okay? Let's do one more. What's log sub 1000 of 1, 2, let's see. 0, 0, 0, 0, 0, 0, 0. So I have 7 zeros. Well, again, 1000 raised to the x power, so let's call this number x, okay? We rewrite this in terms of exponents, so 1000 to the x power is 1 followed by 7 zeros. When we have something like this, where we're trying to solve for x, the exponent, and we have that these two numbers are powers of the same number, in this case they're powers of 10, we want to use the technique of rewriting things in terms of powers of 10, as 10 raised to some power. So 1000 is 10 cubed, 1 followed by 7 zeros is 10 to the 7th power. So we can rewrite this equation as 10 cubed raised to the x power is 10 to the 7th power. And I can rewrite this as 10 to the 3x power equals 10 to the 7th power. That tells me that 3x is equal to 7. Divide both sides by 3, I get 7/3. So those are some problems to practice using the logarithmic notation. So let's summarize what we did. So we reminded ourselves of exponential functions, y equals b to the x, and then we defined the log sub b function to be the function that is what is called the inverse of b to the x. In other words, it takes the y values of b to the x back to the x values. It takes the outputs back to the inputs. So for instance, we've seen that log sub 2 of 1/8 is negative 3, because 2 to the negative 3 power is 1/8. So in general, to calculate log sub b of anything, we ask ourselves what power, right? What is the exponent that you have to raise b to get that number? And we did a bunch of examples of this. And we saw some basic properties of natural log, of logarithmic functions, which is that log sub b of 1 is 0, and that makes sense because b to the 0 power is 1. And in general, log sub b of b to the c is c, because when you raise b to the c power, you get b to the c power. And we just did a bunch of examples where we got some negative values, some fraction powers, some fraction values, and yeah, like in this example, log sub 64 of 1/8, that's negative 1/2, right? So you could get negative outputs, you could get fraction outputs, and that's what we did in this video.